Hello, my name is Evan Miller, and this is our ME 401 Test Engineering final presentation on WhisperLite fuel analysis. Our test was focused on comparing different fuels that can be used with a WhisperLite camp stove. We decided to test white gas, diesel, and kerosene in order to see how efficient each fuel was and identify differences in how they burn. Currently, MSR recommends using white gas. However, we believe kerosene may be more efficient. By calculating their efficiencies, we can determine if there is a better option. Now for a bit of background on WhisperLites and their fuels. So what is a WhisperLite? A WhisperLite is a camping stove made by the company Mountain Safety Research, which has become a very popular camp stove because of its versatility. It is a collapsible stove that only weighs about 1 pound or 16 ounces. One of its more helpful attributes is how it can be easily disassembled, cleaned, and serviced. The manual states that white gas, kerosene, and unleaded auto gas, including diesel, can be used with a WhisperLite. We decided not to test gasoline because it is an explosive chemical which can be hazardous. In order to perform this test, our group needed to become familiar with how a WhisperLite operates. One slight setback we ran into was that the fuels required a different nozzle to burn, so in between tests, we needed to take the WhisperLite apart, replace the nozzles before switching the fuels. So how does a WhisperLite work? The diagram below shows the fuel cycle that occurs when using a WhisperLite. The first step is priming. This requires the user to manually allow fuel to pool in the lower dish of the stove and then light it, creating an open flame. The flame will then heat a tube that contains the liquid within the pressurized fuel canister. This causes the fuel inside the tube to be heated from a liquid to a gas phase. Once the flame dies down, the user must open the valve, which causes the fuel to be expelled out from the burner head. Then the user must ignite the gas and adjust the valve to reach an evenly spread blue flame around the burner head. So why are we interested in testing other fuels? From a consumer's perspective, there are several considerations when choosing one fuel over another. The three main categories are cost, weight, and efficiency. The table here shows that diesel is the cheapest fuel comparatively. It is also readily available at most gas stations, whereas kerosene and white gas might not be easy to find. When comparing their densities, they are relatively similar. The density of fuel is important because the more someone has to carry on long camping trips, the more space and weight it takes up. This brings us to fuel efficiency. If a particular fuel is more efficient, it will take less time to cook, and there will be less weight to carry. Some additional considerations would be how clean the fuel burns, whether it has hazardous odor to it, and whether it is safe to burn. So what does each fuel offer in terms of efficiency? Well, these fuels are often used today. White gas is specially designed for most camping applications such as lanterns and stoves. It burns clean, evaporates quickly, and has minimal odor to it. Diesel is commonly used in motor vehicles and considered a safer fuel because it is less flammable and less explosive than gasoline. It also has the highest energy density among the three candidates. Kerosene is commonly used as fuel for heating, cooking, and a light source. It has a lower flammability than diesel, but also burns hotter. The efficiency equation shown roughly describes how we ran our experiment. The main idea being change in heat energy over the change in mass energy will result in the fuel's efficiency.
Hi, my name is Sean Murphy, and we will now move on to the experimental test plan. So this is the test setup that we used in order to conduct the experiment. Pictured to the left is the WhisperLite without the windscreen, and to the right it is pictured with the windscreen. In both test setups, you can see The fuel canister sat above our scale, which took constant measurements throughout the experiment. And directly to the right of that is our multimeter connected to the thermocouple, which sat inside the pot, which again took constant measurements throughout the experiment. And directly to the left of that is the WhisperLite we used to conduct this analysis. All right, next, we will move on to a summary of our test plan. So this test plan involves monitoring a change in temperature and mass as the pot of water heats up. Heating the water will follow a basic heat transfer and thermodynamics model. The temperature will be monitored with a thermocouple, while the mass of the fuel will be monitored on a standard scale. Starting and end masses are more important measurements for analyzing fuel efficiency and will be recorded immediately before and after every trial. Mass and temperature measurements will also be recorded at 30-second intervals and then plotted for further analysis, as shown later in the presentation. The pot is heated to 90 degrees Celsius in order to limit any error we would have by boiling the water. And this allows us to calculate our energy a little bit easier. And our test will also consider how much use the windscreen is in order to improve the efficiency of the boil. All right, so shown here is the equipment we used. So we used a WhisperLite stove, fuel bottle, pot, lid, thermocouple, multimeter, stopwatch, scale, graduated cylinder, and then for fuels, we used kerosene, white gas, and in order to safely transfer the fuel into the canister, we used a funnel for that.
Hello, I'm Mark Ramsberger, and this is the procedure for the WhisperLite fuel analysis test. So the first step in the procedure is to assemble the test setup. So you want a picture of the basic test setup assembly can be seen to the right. You want to put the thermocouple both into the multimeter and inside the pot. Set up the scale so that it's zeroed out and ready for the fuel bottle to go on top. You want to get your stopwatch ready, set up the WhisperLite, and then get out the fuel canister with whatever fuel you're going to be testing for this experiment, and the pot with water to be boiled. So once you have all your equipment out, you want to both measure the mass of the empty fuel canister and the fuel pump and the hose, which is the brass piece coming off of the fuel canister. Next up is setting up the test. So you attach the pump assembly to the fuel bottle after you've poured in the whatever fuel you want to use. You pour in the fuel, attach the pump assembly to the fuel bottle, then connect the pump assembly to the burner assembly with the fuel line, which again, the fuel line is the brass piece coming off of the fuel bottle, which is the red piece on the red bottle on top of the scale. So the next thing is to pressurize the bottle. First, you want to make sure that the valve is fully closed so that no gas escapes while you're pressurizing it. And then you pump the nozzle 50 times, pushing it in and out, making sure it's a full stroke every time, and that ensures consistent starting pressure inside of the bottle. Next, you mount the pot with a liter of water onto the WhisperLite. Let it stand for a second, and then you measure the initial temperature. The next thing is recording a few other values. You want to zero the scale, set the fuel canister on the scale, and then record the initial mass of the fuel canister again with it attached to everything. And that's going to be used for the graph as the fuel burns. So for running a trial, you want to start the WhisperLite. So the first step to that is to open up the valve and let the fuel into the line, but you want to make sure that none of it is in the primer cup, or you want to try to have none of it in the primer cup. Then the next step is to take a pipette or some sort of a syringe and put a 0.5 milliliter to a milliliter of fuel into the primer dish. Then you light the primer, and a flame will start, and it will start heating up the fuel inside of the tube. Once the flame dies down, this process should be done, and then you open up the stove, and you'll hear hissing as the fuel escapes. So when you hear that, you want to light the top of the burner, and ideally you should see some blue flames coming out of that there. And right once you light it, you want to make sure the pot's on top, start the timer, write down the initial temperature and initial mass, And then every 30 seconds, we're also going to measure the current temperature and current mass from the water and the fuel left in the bottle. And then so we continue that process until the temperature reaches or exceeds 90 degrees Celsius. Then we want to record the end mass on the scale, stop the timer at the nearest 30-second interval, and then turn the dial off and close the WhisperLite nozzle. And then some final measurements that need to be made. You remove the fuel canister and the pump assembly and place the canister back on the scale to record the final mass of the fuel in the bottle. So that's how you run one trial. Then you repeat steps 2 to 4 for all the different conditions that we can have, which is white gas, kerosene, and diesel, and with or without a windscreen for each of those three. One thing to keep in mind is you want to make sure you replace the heated water with tap water so that you're heating it up again. And it is recommended that you leave the WhisperLite cooling long enough to be able to clean it after each experiment and before the next one. And then finally for cleanup, you pour the leftover fuel of whatever you're using back into the proper container, then let the WhisperLite cool, clean it with isopropyl alcohol, and then put it back into its container.
Hello, my name is Adam Tarsik. In every experiment, safety is the #1 priority. As such, before we started any trials of the experiment, we did a thorough safety analysis and came up with a plan to mitigate the hazards to ourselves and others. Here is a list of our potential hazards, the likelihood of them occurring, the consequences, and the overall hazard rating. First, we have fire and hot surfaces. Operating the WhisperLite requires an open flame, which heats up the unit itself. Also, as we were heating water in a pot on the stove itself, we had to take into consideration how hot the pot would get, as well as the water, to prevent any burns or scalds. Also, since the WhisperLite uses multiple different types of chemical fuels, safety precautions had to be put in place to prevent any exposure to either the harsh chemicals resulting in chemical burns or the breathing of any chemical fumes, which are obviously bad for the body. The WhisperLite stove also requires the aforementioned chemical to be pressurized before they can be burned. The pressurized container, if it failed and depressurized, could result in injury. However, it was decided that the likelihood of this is very low. Nonetheless, it still had to be considered. So here you can see the hazard mitigations that we took. To prevent any fire from spreading, you can see we had a fire extinguisher in the bottom left there. Also, let me move up there. Not in any of these pictures is there was a spigot with a water and a bucket full of water behind us. To prevent any chemical burns, we had masks, gloves, and closed-toed shoes. We're also outside to prevent any exposure to any chemical fumes, as well as prevent any carbon monoxide exposure or anything like that. As for the pressurized bottle, we made sure to standardize the amount of pumps to pressurize the bottle with the proprietary pump to prevent any overpressurization of the fluid inside that might pose any danger to any of us. Overall, we took safety very seriously in this experiment.
For our results and conclusions, we see that the white gas was our most efficient fuel without the windscreen, which was kind of odd, but we'll get to that later. We have the numbers for all of the presented efficiencies here. We can also see some of the data about the fuel use in grams for each of the trials, which is nice. And we can start to look at our mass over time graphs, which are helpful to understand kind of the linearity of how the fuel is being burned. We can kind of see that it's vaguely linear, which suggests that the WhisperLite is burning at a consistent rate, which kind of adds to our assumptions about the energy use and everything, which is good to see. This one's a little bit odd, but it's still mostly linear, and we did have some troubles with our scales as we were with the scale setting it up, as we couldn't get it perfectly balanced. So these are kind of rough data points, but it does give us somewhat of an idea of what we are seeing as the WhisperLite is consuming this fuel. So as stated earlier, we see that the white gas had the best performance. The diesel and the kerosene were very hard to work with, which kind of knocks them even worse than their efficiency rating for us personally, but as possible users of the device. But in general, the efficiency rating was kind of what we were looking at. It is just nice to note that they are not as easy to use, which kind of makes them not as viable as a fuel, on top of the efficiency issues. For the most part, the windscreen did increase the efficiency of the WhisperLite, which was very good to see, because that's something we anticipated, and kind of makes us feel better about bringing that extra weight into the backcountry. If we're looking at it like that. It was a little odd that the white gas trial had lower efficiency with the windscreen. That's something that we probably should have addressed by doing multiple trials of all of the different fuels. Unfortunately, we didn't make the time to be able to do that. Kind of a fault on our end. But it may also have, there's probably a lot of, or there is a lot of other factors that could have contributed to that, like mistakes made, just human error. So it's hard to pin down exactly why that happened. Another improvement that we could have made is, or maybe not we could have made, but could be made on the experiment, is find a way to conduct it in an environment in which we can control some of the environmental factors that we couldn't while testing outside, such as wind and a consistent starting temperature, a consistent pressure that will vary day to day just outside. But if we could have used some sort of testing rig, that would have allowed us to control some of those variables, but that was not feasible for our experimental trial. And as said, collecting multiple trials would have greatly increased the accuracy of our data, but there was a bit of a time constraint, which did not allow us to do that.